Greetings and welcome, friends. We are in section 2.3 of the Big Ideas Algebra 1 book. Today, I know you can't wait. You are so pumped. Today we are solving inequalities by multiplying and dividing. All right. You'd say, well, Mr. Waddy, I already know how to do this with equations. I think I know how to do this for inequalities. But beware, my friends. Beware. It's not as easy as you might think. Well, there's a trick out there, and I don't want you to fall into the trap. Here we go. It says multiplication and division properties of inequality when C is greater than 0. Okay? Another way to say that is positive. All right, so you don't have to write this down, but I recommend maybe when we do the examples to do so. So it's with words, it says multiplying or dividing each side of an inequality by the same positive number, positive, emphasize, produces an equivalent inequality. Okay, so if I have negative 6 is less than 8, true statement. Multiply both sides by 2. Is negative 12 less than 16? Yeah, still a true statement. Okay, how about this one? 6 is greater than negative 8. True statement. Divide both sides by 2. 6 divided by 2 is 3. Negative 8 divided by 2 is negative 4. Is 3 bigger than negative 4? Still a true statement. Therefore, if you have an inequality and you multiply both sides by C, then the inequality stays the same. That's the idea. As long as C was positive. All right, notice this was the requirement there. When you're multiplying both sides by a positive nombre, okay? Hombre, here we go. All right. All right, here we go, here we go. I'm bringing an example. This is going to be the best. All right, solve. Here we go. X divided by 8 is greater than negative 5. All right, I got this. The operation at play was division. The inverse of division is multiplicado. Multiply both sides by 8 here. And the 8's cancel out. I will end up with x is greater than negative 5 times 8 is negative 40. Okay? Now, did I multiply by a positive? Yes, right? I multiplied both sides by a positive 8. There was this little minus sign over here, but that was not what I multiplied both sides by. Okay, we multiplied by a positive, so our little situation that we were describing applies. Let's see. Let's look at this one over here. X is being multiplied by 3. The inverse operation of multiplication is division. So divide both sides by 3. I'm dividing by a positive. Okay, I understand there's negative in this fraction over here, but I'm dividing by a positive number. Negative 24 divided by 3 is negative 8. It is greater than or equal to x because these 3's canceled out. Let's flip it. X is less than or equal to negative 8 when I flip it. Right? When I flip the whole thing around, the inequality flips too. Let's giraffe this. Let's see, where's my ruler at? Oh man, guys, I love having this straight edge ruler. So great. I realized the other day, actually, my Facebook profile, in my description, it describes me as being straight edge. And I was like, wow, I probably wrote that like 7 years ago. Still accurate, but I thought that was interesting. So let's see, 0, negative 40 would have been to the left of 0. And my solutions here, I'm saying x is greater than negative 40. So I would have put an open circle at 40 and shade it to the left. Shade in. Now. Okay, so there we go. X is greater than negative 40. Let's look at another one. X is less than or equal to negative 8. So 0, I'll throw over here. Negative 8 is to the left. See, I'm trying to just make the graph interesting. Notice this is not the same scale as this one over here. You don't have to throw in all the little tick marks because, yeah, I'm fine with that. I know what you're talking about. Let's see, so less than or equal Equal tells me that it's a solid dot, less than to the left. All right. And if I was to check a solution here, zeros in the solution set of infinitely many solutions. Does 0 work up here? 0 divided by 8 is 0. Is 0 bigger than -5? True. Over here, 0 is not in the solution set. Watch this, though. I can still do my proof by contradiction check. 0, if I plug it in, I am not expecting it to work. 3 times 0 is 0. Is -24 bigger than or equal to 0? No. Therefore, proving that I was right about this not being in the shaded region. Okay, so good stuff. So yeah, it seems to work out just fine. But let's get interesting here, friends. Why do you think they took so much time to specify positive and make that distinct? Well, friends, behold! Multiplication and division properties of inequality when what? C is less than 0. We'll describe that as negative. When multiplying and dividing each side of inequality by the same negative number, the direction of the inequality, symbol must be reversed. What? This is crazy sauce, friends. You gotta flip that sign. So let's see. Quick example. I'm not gonna read all of this. -6 is less than 8. Multiply both sides by a negative. Notice they flipped the inequality. Negative times negative positive. Positive 12. -2 times 8 is -16. And notice they flipped the inequality and they were correct because positive 12 is bigger than -16. Same thing applies over here. I'll let you pause the video later and take a look at it. So here's the idea. If you have an inequality and you have a negative number that you're multiplying both sides by, you notice, what? What happened to that sign? You flip it. Flip that inequality, right? And we notice the same theme throughout. If I divide both sides by a negative, the inequality flipped. If I multiply both sides, right, inequality flipped. Here they just did all the work of like, okay, greater than, less than. Actually, wait, did they make a mistake? Aren't one of these supposed to have an equal to sign on it? What was the one up here? Yeah, I feel like this is a typo. I think they were supposed to have equal to signs on some of these. But really, I mean, it's the same idea. We're just describing inequalities in general. Oh, this one, and this one, and this one, and this one. There we go. Whatever. We got it. All right, so let's do some math here. Man, I'm so excited, guys. And see, isn't this great? Like, even though like we're on a different chapter, we're still rehearsing a lot of stuff from chapter 1. So you still get to practice those skills. It's gonna be fun. All right, 2, less than y over -3. The operation at play is division, not subtraction, okay? So to undo dividing by -3, I'm going to multiply both sides by -3. Notice if I'm writing multiplication on the right-hand side here, I put it in parentheses because I don't want it to look like I'm saying subtract 3. I'm multiplying by a -3. And over here, I could just write -3 outside parentheses. And I wouldn't confuse that as a subtraction sign, right? That's multiplication. But if you want to just throw parentheses around it, you can, if that makes you feel happy. So let's see, multiply both sides by -3. -3 times 2 is -6. These negatives cancel out, those 3's cancel out, I get y by itself. But notice, behold, this inequality, flip it. What? That's crazy. We just flipped that inequality. And then we should still write this on the left-hand side for the variable. So y is less than -6. Notice I flip the whole thing, including the sign when I do that. So when I multiply both sides by a negative, you flip the inequality. Ooh, goodness. Sneezes Wow. I hope someday someone compiles all of my sneezes from all of my 500 or 600 videos and just makes like a compilation of just like 5 total minutes of sneezes. Like that would be the best. Someday. Let's see, best of sneezes for 2016. Let's see, for question B, -7 is being multiplied by y. The inverse operation is dividing by a negative. And so I'm going to have y, the negatives cancel out, 35 and 7 is 5. And watch this, flip that inequality. I actually was talking to another teacher the other day about these, and she said that like she has her entire class like shout out like it's a game show and say, flip the inequality, and like everyone's like pumped about it, but really it was just her and like she got like 2 students to say it and not shout it. But either way, when you multiply or divide both sides by a negative number, we flip the inequality. Wow, it's so great. I love it. Let's see. Oh, they did ask us to graph real quick. Alg1 these. And I think I've got some more examples like this, but I think we'll just jump right to the word problem. So that way you guys get some time for rehearsal. Let's see, so I've got 0, I've got -6. Well, I've got my white ink equipped. I'll throw the lines on this one as well. Let's see, 0 and 5. And y is less than -6. Open circle. Oh, classic mistake. Classic Waddy blunder. Open circle, shaded to the left, right? And this one would be a solid dot, closed circle as we say, because of the equal part, and shaded to the right. Greater than is towards the positive x-axis, right? This positive numbers, negative numbers over there. All right. Let's, ooh, I'm so excited about this next question. Wow, this girl's got a camera. Wow. Guys, example 3, here we go. You're gonna see this problem and believe it. All right, look at that. There she goes. She's taking a picture. Does this even relate? Okay, yes. I was like, you work at a summer job. I'm like, I hope this somehow relates to what this girl is doing. You earn $9.50 per hour at your summer job. Write and solve an inequality that represents, ooh, here we go, represents the number of hours you need to work to buy a digital camera that costs $247. Okay, so, variables. I feel like that's not quite yellow enough. That was still in the orange range. So, my variable, let's call it H. I guess, because it's hours, number of hours needed to work. And what are we earning here? We're earning, are you getting paid in like breadcrumbs? No, it looks like you're getting earned in dollars. Oh, but this is number of hours. So yeah, so this is measuring time, not money. Okay, I almost went completely the wrong direction there. Let's see, then I write my equation, but in this case, it's an inequality. So let's see. So I have the variable H. I get paid a certain rate in dollars per hour. And I want to earn at least $247. Right? Notice I just said at least. That's inequality language, my friends. So here we go. If I take the rate of pay, okay, so that's $9.50 per hour, multiplied by the number of hours. That's this, when I multiply those things, that will represent how much money I earned total over those hours, right? And I want that to relate to 247. How? I want this to be bigger than or equal to that number. Bigger than or equal to that number, right? If I don't have that much money, Mr. Digital Camera Salesman is not going to sell me a digital camera. Now check out the units here. I just want to point this out. This is measured in dollars per hour. I'm multiplying by hours. And if I do that, notice what happens to the units. Dollars over hours multiplied by hours. These H's, man, I always keep forgetting that. These H's cancel out. And what would this measure in? What unit? The H's cancel out. Dollars per hour times hours. The H's cancel out. This would be measured in dollars. Dollars. Okay? All right, so the units make sense. Let's solve this inequality. So H is being multiplied by 9.5. Let us divide both sides by 9.5. 0 if you want. I guess I could have even gotten rid of the 0 there. Divide by 9.5. I will get H. Now, did I multiply or divide by a negative here? I divided, but was it negative? No. So do I have to flip the inequality? No. Okay, so the inequality stays the same. It's going to be H is greater than or equal to, I just reached for a calculator for that one, 26. And so the answer to the question, my friends, is you must work at least, that means can equal, must be equal or bigger, 26 hours. All right, so that is a word answer to a word problem. And that's how those work. Words. All right, well, thank you for watching. Mis amigos de Internet. Bye-bye.